we're told in this problem that the two triangles shown are similar to each other. The first thing that we'll do then is write a similarity statement. Well, in the previous unit, you've written a congruency statement. A similarity statement is written very similarly, no pun intended. And so let's go ahead and start with our triangle. And as I asked you guys to do in the previous unit, the first triangle, I'd like it if you could list it alphabetically, so RST. Although the order of the first triangle doesn't really matter as long as you're consistent with the second triangle. The symbol for similarity is not the congruent symbol, so do not write that. They are definitely not congruent to each other. Instead, the symbol for similarity is just the squiggle. So we're going to say triangle RST is similar to triangle. And now this second one does need to match up. And I can see that angle R matches up to X, and then if I continue my way around the triangle, that continues to Y and Z. So there's my similarity statement, almost identical to writing a congruency statement. Next up, they asked me to list the pairs of congruent angles. Well, when two figures are similar, all their angles are still congruent to each other. So we can match this up the same way we did last time. Angle R is congruent to angle X, and notice I did use the congruency symbol right there because those angles are going to be the same. Similar figures don't have the same side lengths, but their angles are the same. Next up, angle S would be congruent to angle Y, and feel free to use the congruency statement to help you, or the similarity statement to help you if you can't tell from the diagram. Angle S is the middle letter there, so angle Y would be what it matches up to, the middle letter. Finally, the last two angles that match up are angles T and angle Z. So there's all three angles, matched up. Next up, they asked me to find the scale factor, or the common ratio between the sides. To do that, let's find two sides that correspond and set up a ratio. So I need both sides to have numbers on them. In this case, it doesn't matter since all the sides have numbers on them. But let's match up those two sides. They are corresponding. And so side length of 25 needs to match up to the side length of 15. Now, of course, if you gave me that as your scale factor, well, you'd be wrong because that still needs to be simplified. So simplifying 25 over 15 gets me a scale factor of 5 to 3, or 5/3. If I want to write that as a ratio with the colon, I can certainly do that as well if I'd like to, 5 to 3. Now, even though that is the scale factor, let's go ahead and match up all the sides just to see that we do in fact get the same scale factor. And this would be a great way to check too. So let's match up the bottom two sides. Those two sides should be in the same ratio, in the same proportion. So let's match up 20 over 12. And notice I'm putting that 20 in the top. I don't have to, but because I put the bigger number on top last time, I have to be consistent and put the bigger number on top this time as well. 20 over 12 does in fact simplify to 5/3, so that's a good sign. And let's match up our third side as well. Again, just matching up all three sides just to see that this does work out. The third set of sides that match up are that 30 and that 18 side. And again, because I put the bigger number on top all along, I need to be consistent. 30 over 18, again, it simplifies to 5/3. So that's good. All the sides are in the same ratio, in the same proportion. The final piece of this is going to be to write a statement of proportionality for the sides. What this means is I'm not going to match up the sides as being congruent to each other like I did with the angles. They're not congruent. I can see the sides are not the same length, but they do have the same scale factor, the same ratio as I just found. And so let's match these up, and I kind of already color coordinated my sides, so let's use that to help me out. So going from the big triangle to the small triangle, I'm going to say that side TR, and that matches up to the other blue side ZX. That they're not congruent to each other, but that ratio is equal to the ratio of all the other sides. So if I move along to the green side along the bottom, side RS is going to be in the same ratio with XY. And then finally, for the last piece of this, I'll go to my purple sides, and those were sides, let's see, TS and segment ZY. And so that's my statement of proportionality, just showing that all three sides are not equal to each other, but they do all have the same ratios.